How is a three-phased asynchronous motor connected to the electricity supply, and how is it protected so that its service life can be prolonged? We will attempt to answer these questions via this video. We will first look at how the motor of a pump is wired from the electrical cabinet. Then we will look at the electrical protection devices within the cabinet. We will then conclude with an energy loss balance and motor efficiency calculation. To supply electricity to a three-phase asynchronous motor, it must be connected to the pump's electrical cabinet via 1, 2, and 3-phase wires. Where the wires are connected to the motor, there are 6 terminals on a unit, which correspond to 3 internal stator circuits. The electrical wires between the electrical cabinet and the motor, also called couplings, are connected to these terminals. 2 types of couplings exist for a pump's motor: delta, triangle, or star. Motor coupling is carried out using metallic clamps to connect the 3-phase electrical power wires to the terminals. The type of coupling is indicated on the motor's information plaque. This coupling depends on the motor and the electricity supplying the pumping facility, from the electrical cabinet downstream to the transformer. For star coupling, each stator coil or winding is supplied by a single voltage between phase and neutral. For delta coupling, each stator coil is supplied by a phase-to-phase voltage. On the information plaque, both voltages that can be supplied to the motor are usually found. Therefore, we can see the voltage that can be supplied to delta coupling and star coupling. Consequently, according to the electricity supply's voltage, for example, 230 volts, 400 volts, or 690 volts, we can choose the most suitable coupling for the pump motor. In order to protect a facility when starting up a pump, the motor is connected to an electricity supply via an electrical cabinet containing safety and control devices. A motor is protected and controlled by the motor starter. 2 options are possible. The first option includes a fuse holder disconnect switch that ensures the separation and protection against short circuits, a contactor that controls the motor, and a thermal relay switch which protects against overloads. The second option contains a motor circuit breaker which has a separating function that protects against short circuits and overloads, and a contactor. In addition to the motor starter and electronic devices such as a starter and variable speed drive, star-delta coupling can also be found in older facilities. This type of coupling enables 3-phase electric asynchronous motors to be gradually started up in 2 phases in order to limit overloads. A first phase, lasting a few seconds, enables a motor with star coupling to be started up. Once the motor has started up, the control device triggers the delta coupling via a delay timer switch. The control device must include a mechanical and/or electrical interlock in order to prevent both couplings occurring at the same time. Once the motor is connected to the electricity supply, it is important to determine the power that is actually supplied to the pump. Indeed, the electricity supply provides input power at the motor's terminals. Inside the stator and rotor, heat-type energy losses called Joule losses and magnetic-type energy losses called iron losses occur. Even mechanical-type losses occur in the shaft connecting the motor to the pump, mainly due to friction. The actual power transmitted by the motor to the pump after deducting these successive energy losses is called useful power. This is calculated by multiplying the active power provided by the electricity supply by the motor efficiency. The yield is given by the manufacturer according to the motor's load and can be seen on the motor's information plaque. Let us summarize together. Wiring between the electricity supply and the pump's motor is called coupling. There are two sorts, star and delta, in a triangle. The coupling to be used depends on the motor's characteristics and the electricity supply. The electrical device called a motor starter, fitted in the electrical cabinet, protects the motor and electrical equipment. Energy is lost throughout the motor before arriving at the pump, in particular through heat and friction. The actual power delivered to the pump by the motor's shaft is called useful power.